Alright, welcome back. So in this video, I'm fixing biometric authentication in my app because right now, it's kinda fake. Here is how it currently works. Biometric is off by default, and when you turn it on, the app asks for your PIN. That PIN unlocks the app master key, and then we store that key using Flutter secure storage. But here's the problem.
I don't want peace. I want problem!
That storage isn't actually tied to biometric. Like there's no OS level enforcement or anything. So yeah, biometric here are just a check, not real security. Let's fix that. Instead of handling everything ourselves, we're gonna let the OS deal with it. Basically, after a successful biometric check, the OS handles the crypto operation for us. No keys exposed, no weird shortcuts. To do this, we'll need to go into the native code. Yeah, Kotlin time. First, I'm setting up a simple backbone channel just to connect Flutter and Android. Nothing fancy here. Alright, now let's get into the core part. For the encryption part, I'm using AES, is that how you spell them, in GCM mode. When setting up the key, we can tell Android that user authentication is required. And if the device supports Strongbox, we can use that too for extra protection. Next, we make sure setup only runs once by checking whether the key already exists. After that, we create the cipher and hook it up to Android Biometric Prom API. And yeah, Android really loves callback. This callback is even supposed to be its own class, but thankfully Kotlin lets us use anonymous objects here. So once the authentication succeeds, we encrypt the data, save it to storage, and then clear the memory buffer afterward. And finally, we trigger the biometric prompt using the authenticate method. Now I'm just wiring the encrypted blobs into the Android data store. Pretty straightforward stuff, so I'll skip ahead a bit. Now I'm writing this into the Flutter plugin. For now, I'm just using a hard-coded test value to make sure the workflow works first. The rest is mostly plugin boilerplate and safety checks, so I'll skip it again. While doing this, I realized Flutter actually mentioned using Pigeon for type-safe code generation. From this to this, which would be nice to know earlier. Maybe emphasize this as recommended. I also changed the Strongbox setup a bit. Originally, I required the Strongbox support entirely, which obviously breaks on devices that don't have it. So now it's just optional. If the device supports Strongbox, we use it. Otherwise, we just fall back to the normal Android Keystore. One more thing, we still need to check whatever the device actually has biometric enrolled. Otherwise, Android just throws an exception at us. Thankfully, integrating it into Flutter is much cleaner now thanks to the earlier Pigeon refactor. We can basically just call the host API directly and that's it. And finally, the prompts show up correctly. So at least the native side is working now, but of course, the actual in-app biometric integration still doesn't work yet. Okay, next up, the toggle itself. First, we need to persist whatever biometrics are enabled or not. And since we already went native for everything else, might as well keep using data store here too. So we wire it through the host API, then initialize the state using has biometric data. And there we go, the biometric state now persists properly. Disabling biometric is actually pretty simple. We just remove the data store entry and that's it, biometric is off. Now the more important part, biometric unlock. What we need to do here is fetch the stored key, then decrypt it through the Android Keystore gate by Biometrics. After that, we pass the decrypted key into the database layer to unlock the app. The code is basically the same as encryption, just running in decrypt mode. But instead of callbacks, I switched to suspend function. Much easier to work with and cleaner control flow. And of course, wrap in try-catch so failure don't explode the apps. Once that's done, we go back to Pigeon again to call the host API. I also wrap the result in a success or failure type, so we don't rely on exception handling on the Flutter side. For testing, I just run it in debug mode and hit a breakpoint. And yup, we retrieve the plain text task we set earlier. Alright, time for the actual biometric unlock feature. First, I replace the hard-coded task value with the real parameter. Then on the Flutter side, we pass the decrypted blob into the store manager so the database can unlock itself. Now let's test it properly. First, we need to enable biometrics again so the encrypted value gets regenerated. And now for the moments of truth. There we go, app unlocked. There's still a few things left to clean up, but I'll save those for another time.